So thank you. So first of all, big shout out to Vyas because I've been, this is actually the kind of conference that I was more directly involved in, just like ideation and planning and everything. Vyas has been running Vue Amsterdam for the Vue community over the past few years, and every time it's been a blast. It's been a very smooth experience, and this time, I was a bit more involved, so I get to witness even more of how much work and coordination and that goes into organizing conferences like this. So thank you, Vyas. Okay. So today, I'm going to be talking about Vite, of course, and how Vite is evolving beyond a build tool, right? I think many of you have heard many talks yesterday, and there will be many more talks today about what's going on in the ecosystem. So this talk is mostly going to be focusing on Vite itself, and in particular, the things we've been working at VoidZero on how to sort of, A, change Vite from the inside out, and 2, expand Vite into something that is more than a build tool, right? I assume many of you have watched the documentary already, so you kind of know the backstory. I'll skip all of that and just fast forward to now, where at VoidZero we're working on a lot of things, right? So we're maintaining Vite, we're maintaining Vitest, we're working on Rolldown and OXC. So a quick recap of what's been going on in the past several months, right? So the state of Oxlint, it has now more than 600 plus ESLint compatible rules and growing. We shipped type-aware linting. Still experimental, but it works, right? It's powered by TSGo linked, which is based on TSGo, the version of TypeScript that the Microsoft team is actually rewriting the entire TypeScript compiler in Go, which is orders of magnitude faster than current TSC. And TSGo linked is built on top of TSGo itself by essentially vendoring the code base and then adding linting capabilities on top of it by directly leveraging the type information from the TSGo compiler itself. So the benefit of this is orders of magnitude faster type-aware linting compared to current solutions like TypeScript ESLint. And we integrated directly into Oxlint, so you still get the same coherent experience, same configuration, same reporting, except when you enable type-aware rules, we just do the extra work. We're also exploring the possibility to, say, actually perform the type checking and type-aware linting in the same pass. So you don't have to, so imagine today if you run TypeScript ESLint and then run TSC to type check again, you are actually type checking the code base 2 times because type-aware linting and type checking rely on the same set of type information. So why don't we just do it in the same pass, right? Saves you even more time. And we also shipped custom JS plugin. So actually I think it was released yesterday. So if you didn't watch Jim's talk, it's an excellent talk explaining the challenges and the things that we worked on in order to make JS plugins in Rust systems fast. Do watch the talk if you haven't. It's an excellent one. And our team members, Jim and Cam, who both work on Oxlint, are here. So if you're nerdy about these things, go talk to them. Next one is OX format. So this one has been in the works for quite some time. Turns out formatters are pretty complicated because of the amount of edge cases, especially when it comes to comments. So this took us longer than we expected. But the formatter is now at up to 92% prettier test conformance. On top of pretty much being a drop-in replacement of prettier, but much faster, we've also planned to offer more flexible line wrapping options, which is one of the main things people kind of have issues with prettier. And the formatter, on top of prettier formatting options, is also going to cover a lot of the stylistic sorting features that's traditionally kind of in ESLint, right? People use a lot of stylistic rules in ESLint, but we tend to separate formatting and linting into separate concerns, where linting is more about correctness. You want to catch potential errors, whereas formatting is about how it looks. Okay, so we're essentially separating it into 2 different commands. Okay, next up are Rolldown. You've probably been hearing a lot about Rolldown. Alex gave an excellent talk about Rolldown yesterday. The main thing about Rolldown is over the past year, it went from something that's barely stable to now being used in production by companies like Framer. And we shipped more features while keeping it, not just keeping it as fast. We actually made it faster while shipping more features. That's something I'm really proud of. Right? We also made the bundle output much, much smaller. Right? It's also now being used in, say, Angular's build system for experimental chunk optimizations. So just to give an idea of how much Rolldown has improved over the past year, on the top, so top and bottom, 2 screenshots running against the same benchmark, 10,000 React components. The first one is the 1.0 beta 1, which was released December last year. The bottom is beta 42, which is just released a few days ago, right? So this is the time it took to bundle, and this is the output size in bytes. And in short, over the past year, we actually made Rolldown another 33% faster, and the bundle output is 34.5% smaller. This is also including minification. So a lot of work also went into the OXC minifier, which is now used by default in Rolldown. OXC minifier actually has, the best sort of speed and compression trade-off, as we know in the market. Okay, so for Vite itself, it has been quite uneventful in the past 2 major versions because most of the work we're doing actually is focused on these lower-level Rust parts. Vite 7.0 mostly adjusts node and browser support range, and we added a few small adjustments for environment API, and it's now in RC. And in fact, the talk after mine, Jamie is going to be talking about the environment API in more details and what it entails, what it unlocks, etc. Probably the bigger thing that's happening in Vite that's not directly in core, but very closely related, is we shipped official React Server component support via our official plugin RSC. So our team member Hiroshi has been working on this for quite a bit of time. RSC is very complicated, as you know, and we're now in close collaboration with Vite-based RSC frameworks like React Router, Waku, and they're exploring how this can be integrated into meta frameworks built on top of Vite. And finally, Vitest, right? Vitest, the main thing is that the current upcoming 4.0, which is in beta, the main thing is browser mode. Browser mode allows you to run your Vitest tests in actual browsers, right? So you can use JS DOM, but nothing beats actually running it in real browsers. There are also utilities that allows you to easily write end-to-end tests or integration tests directly in Vitest. So you just need the same test runner for both unit and end-to-end tests. There's also visual regression testing. So Vitest is evolving into more than just a unit test runner. It's now a very feature-rich, all-around test runner. So write all your tests. The focus is on performance next quarter, and Vladimir is actually going to be giving a talk later today on more details of what's going on in Vitest. Okay, so and finally, the Rolldown Vite, which is all the work that went into OXC, optimizing OXC, which powers Rolldown, optimizing Rolldown, and eventually the very reason we started doing all of this is to get Rolldown into Vite so that we can finally make Vite fully Rust powered. Now, this version of Vite, which is temporary package name Rolldown Vite, we've been publishing it for a while. Many of you probably have already tried it. Some of you already using it in production and seeing very noticeable gains. It's quickly approaching full compatibility as we continue to port a lot of the Vite internal plugins, which were previously written in JavaScript, to Rust. So it's internalized in Rolldown. And now, in the latest version of Rolldown Vite, these native plugins are enabled by default, right? That's where a lot of the performance gains come from as well. So we're seeing up to 22 times faster production builds in real-world apps. Even huge apps, complex apps like Linear are seeing up to 7 times faster builds. So Rolldown Vite is going to ship soon as Vite 8 beta, which means when Vite 8 stable comes out, it's going to be Rolldown powered. And by that time, Rolldown Vite, the package, will be deprecated, and Vite 8 officially is fully Rust powered. Okay, so another big thing we've been working on with Rolldown, in Rolldown Vite, is what we call full bundle mode. right? So many of you know that Vite, the dev server, started out as using unbundled ESM. That's one of the main selling points. Unbundled ESM has a few interesting characteristics in that it kind of has fine-grained caching by default, right? When you do incremental compilation and hot module replacement, unbundled actually has some natural advantage in that. And assuming the browser is able to process the network words fast enough, unbundled is a very, very feasible model for doing development. Unfortunately, it has its own limitations. And the limitations really start to show off when you have extremely large apps. I know not everyone are building extremely large apps, but like say Linear actually loads like thousands or tens of thousands of modules during development. And the bottleneck is not in Vite, actually. The bottleneck is in the browser where it just cannot handle this many requests in parallel, right? Every request comes with the overhead of handshakes, TCP protocol processing, and then cookies, headers, blah, blah, blah. So it quickly adds up. And there's also parallelization limitations on the server that's actually serving those modules. So with these factors combined, it's actually out of Vite's control to optimize the initial page load speed when you simply have too many modules in unbundled mode. So full bundle mode is a new mode that we have been working on, which leverages Rolldown to actually bundle your code the same way as you would in prod. But we had to actually invent a new hot module replacement format because Rolldown outputs ESM, and we do not want to use different output formats between your production format and your development format because the consistency is important. If you've looked into how hot module replacement works, Webpack actually uses a custom format to be able to do hot module replacement. So we kind of have to come up with a whole new hot module replacement mechanism with Rolldown's output format, inspired by Vite's own unbundled hot module replacement implementation. Long story short, we're able to achieve 15 times faster server start, 10 times faster full page reload for, say, in this specific benchmark, 10,000 React components. Again, as you can see, in unbundled mode, it takes 32 seconds to even load the page because there's simply too many requests. But now it loads around 2 seconds. And Leaf HMR actually is even faster than the unbundled ESM. This is important metrics because the new HMR implementation, even in full bundle mode, remains decoupled from the size of the whole bundle. It is constant. No matter how big your app is, the hot module replacement stays instant. Okay, so some stats to look at, right? So over the past year, so Vite is now at 36 million weekly downloads, Vitest at 16.5, Rolldown at 1.7. XC, this is combining the individual NPM packages that we publish, like the resolver, transformer, parser, etc. Combined, we have close to 6 million. And this is actually excluding some Rust usage, because I know there are companies actually using the Rust crates directly in their own custom Rust-based toolchain as well. But in short, both Vite and Vitest are already mature in production, but they're still seeing over 100% growth in the past year. Rolldown, a year ago, there were barely any downloads, and now we are at 1.7 million. So that's a huge bump. OXC has seen 14 times more downloads over the past year. So a lot of growth, right? And this is kind of the big picture of what we've been building. We've been, building all these lower level things. We've been building Rolldown. We've been improving Vite and Vitest, and we're finally getting all these things into Vite and Vitest, and in turn makes the frameworks and tools and building on top of Vite and Vitest more powerful. But all of this can be, combined into something that's what is the thing that we set out to do, right? So the VoidZero company was the slogan that we created company with was we want to do unified toolchain for the web, right? If you think about JavaScript tooling, if you talk to, say, a Rust developer or a Laravel developer or Rails developer, they would make fun of JS ecosystem. They would say, you need to download like 5,000 NPM dependencies just to be able to get Hello World working, right? And that's something that, I personally have always also felt kind of guilty about, like when I built Vue CLI, we had like hundreds of npm dependencies, and like how slow it installed is what drove me to work on Vite in the first place, right? So my personal desire has always been to simplify things so that we can, spend less time messing around with just preparing to actually do the work. We want to actually do the work instead of preparing to do the work. So the unified toolchain is designed to do that, and we're calling it Vite Plus. So what Vite Plus does is it's a unified layer that's leveraging all these open source pieces that we've been building. And imagine Vite, but more powerful. In addition to dev and build, we now also have Vite linked, powered by Oxlint, Vite format, powered by Ox format, Vitest, powered by Vitest, Vite lib, powered by TS down, Vite new, that's scaffolding and code generation, or also code mods, or adding additional things that you can customize. Vite run is a monorepo task runner and cache system, similar to turborepo/nx. Vite install, currently, we are not building our own package manager. We do recommend you use PNPM, but Vite install is essentially a replacement for Corepack/Anthony's NI package. So when you run Vite install, you probably know Corepack is being removed in Node.js 26, right? So Vite install is just a convenience method for you to say, okay, if I have the package manager field in my package.json, then just use this specific version, and we will just make sure the right package manager is used. And there's Vite UI. That's the GUI DevTools that Anthony has been, talking about yesterday. So we put all these things together in one dependency, one coherent toolchain that's built on the same low-level parser, AST, transform pipeline, resolver pipeline. All of them share the same foundation. They know how each other works. They're designed to work with each other. So there's centralized config. You don't need 5 different configuration files for all of these things. It's just one vite.config.js or TS, and you can have all of them centralized. Okay, so demo time. Words of caution, the demo is really, really rough. So nothing here represents the final state of what V Plus look like. Just want to give you a taste. Actually, the main highlight here is the caching system that I've been working on. Okay, so Vite, I've already installed it globally. Good news is we actually managed to get the Vite-plus package on NPM, so that'll be where we publish Vite Plus from, but right now it's not public yet. So Vite new, I can create a monorepo right off the bat, and okay, just to make things easier, to sort of typical, I'm going to use a React TS app because that's statistically what we see most people use Vite directly with. So Vite Plus project. I'm going to actually remove a few things. So, okay, so when I run Vite install, it invokes the, let's take a look at the code base, right? There are still a few things like this which won't be there really when V Plus is officially out. But let's look at the package manager field, right? It says using PNPM 10.8.2, right? This is a common sort of pain point when we have just so many different package managers and you sometimes switch between projects. Even if they're both using PNPM, they might be using the different versions. And like using different versions of the same package manager can sometimes result in very subtle bugs that you really don't want to deal with, right? So we actually, what we do with V Plus is, first of all, Vite install makes sure it's always installed using the right version of the right package manager. It's also inherently cached. So if the log file and your node modules directory doesn't change, it won't actually run it again. And also because it's the caching is so fast, right? So every command that you run, before any Vite Plus command you run, we actually do the check first to make sure dependency is actually up to date. So you don't run into situations where like you run build, somehow it's not producing the expected result because you change your package.json, you forgot to run install again, okay? Okay, so that is the scaffolding. Now I'm going to go to app's website, right? So this is just a typical React app. So one thing I need to do here is because we're actually this demo is actually just pulling from the current create Vite. So it's including a bunch of things we don't really need anymore. Deleting ESLang, deleting TypeScript ESLang, deleting all the stuff. Okay, so I believe everything else is fine. So let's run Vite install again. And it worked. And if we run again, right? Oh, wait, Vite. Okay, that's a cache hit. So it's instant. Okay, so the next step is just showing you that it actually works as expected. So Vite dev, right? So runs the Vite plus React app. Oop, just gave you a sneak peek of the website. Okay, so the next one is showing you that we can scaffold new stuff. Like if I want to scaffold a new library in the monorepo, right? So it's kind of like generators where I can say packages, utils. So I'm just going to use the default. Whoops. Okay, so whoops. So this is just a typical TS down scaffold. Notice there, again, we're pulling from existing templates, so this is no longer needed, actually. So what we can do is like, we'll just have this, right? When we talk about centralized config, right? So all the Vite lib-related config is in the lib block here. So we can just move this part over here. And if you have test-related config, you just put it here. This is already how it works for Vitest, right? Similarly, if you have linked-related config, you can put it here. So I can delete these, and it would still work. I would say Vite lib, and it bundles it, right? And also generates the DTS. The DTS is generated using isolated declarations and directly transformed by OXC, which means it does not need to go through TypeScript itself. We also bundle the DTS. So this is orders of magnitude faster than generating DTS through TSC itself. Also, the bundled DTS, in case you don't know, DTS files performs better when you use it for type checking. Bundled DTS performs even better than separate DTS files. So bundling DTS actually has meaningful performance implications when you have a really huge project, right? If you have because we just talked to someone yesterday, they have like a monorepo of 700 packages. Imagine all of these are type checked against the source TS. That's slow as hell. So actually bundling them all as single file DTS significantly improves the type checking performance in those monorepos. This is why we recommend this as the default. Okay, so I'm going to then also when we created the library here, we actually see that the workspace was actually updated automatically, and then inside here we can just Vitest. The test would pass. The test is also cached. Notice here, because nothing changed. And then let's use the utils package in our main application. So what we need to do here is go here, add it to dependencies, right? So utils and workspace star. Okay. Now I need to run Vite install again, so it's actually linked. Now we can go into our main application and import it from utils. I think it's my function. Yeah. Okay, my function. Great. So the next step is, now that we've added the relationship between these two packages, we can finally do things like Vite run build recursive. Okay, so Vite from build recursives is able to determine that in order to build your whole project, right, your application, the website, depends on your utils library. So we need to build that first. However, because we just built it just now, nothing changed. So the cache actually hits. And then we need to run the actual build command that's for the website package, which is right here. As you can see, we run tsc first, and then we run vite build. So we run tsc, then we run vite build, and now it gives you a nice summary on the task running. So it tells you that the vite lib actually was cached. So we saved like 377 milliseconds. And okay, no previous cache found for these two because we ran it for the first time. So they ran, but if you do it again, everything is now cached, right? Very nice. Save a lot of time on CI. And notice that, did we configure anything? We did not write a single line of caching configuration. It kind of just worked. The reason it works is because V Plus knows exactly what you're running. You're running the, within our system, like Vite lib, Vite build, all of these things are things that Vite provides. So we know exactly what the inputs are and what the outputs are. And this is also finer grained than what you would probably configure by hand. So in order to demonstrate that, let's go into the utils package, right? So here, I'm going to just change this, okay? I changed the implementation of this function, which means the generated JavaScript, the bundled JavaScript will be different. However, the generated TypeScript definition will remain the same. So what happens if we run the whole build again? Notice that, first of all, the index TS in the library changed, so we had to rebuild the library. However, when we're type checking the main application, notice because the library's type definition did not change, we were able to just cache it. We didn't have to run type checking again because the types did not change. However, because the actual JavaScript at runtime changed, right, we're still able to detect that, right? The generated JS changed. So the application itself needs to be rebundled, but the type checking can be skipped. So this is something actually very tricky to get right, even if you were to write the caching configuration manually with things like turbo repo. But it just works in V+. And the more interesting thing here is, if you look at the script you're writing here, the build script is actually using this end. It's like a multi-step shell script. V+ is able to identify that these are two separate steps and treat these as subtasks that can be individually cached. So we're able to identify this step as an individual, this command as an individual step, and determine the right caching strategy to use in order to do less work. So this is, how far we go with the V+ system. And this is all thanks to how, we built everything from first principle. We control all the way up to the parser to understand what's going on when you run these commands in the V+ enabled project. Okay, so a few other things that we can demonstrate here. For example, if I add a debugger statement here, and I go vite linked, it tells me, hey, no debugger. Notice I did not, this project so far does not include any linting configurations. It's also very opinionated and works out of the box. So no debugger. Okay, I say, okay, I want to disable the debugger. I can just go into the root ViteConf and just say linked rules no debugger off. And now it passes. Great. Centralized configuration. And now if I go in here and also make this an async function, and I say my function dot then, okay, let's see what happens if we run type aware. No folding promise because you did not catch it. So there's potentially an uncaught error somewhere. Okay, let's catch it. Boom. Okay. So now the linked passes. If you run again, cache hit, replaying. And also, if we run vite format, boom, get formatted here. So everything we talked about so far works from the same command, consistently, intelligently cached whenever you run it in the system, one dependency to roll them all. That is V+. Okay. Next steps. What we want to do next is think about the plugin system. Right now, if you write a V plugin, it hooks into Vite itself. That empowers just dev and build. You hook into the transform pipeline. That's most common use case. A V+ plugin will be able to hook into our Vite new command to provide custom generators to customize the code generation, hook into the test runner to add your own customer assertions or test environments configurations, add your own custom link rules, etc. So this is very useful if you have, say, a framework as a V plugin, right? We are giving you all the foundations what you typically need to build a full experience framework, but all of them can be done as a V+ plugin. There's also something we're thinking about called agent mode, right? With the rising importance of having AI-assisted coding working really well. My thesis is that it's a 3-link process. There's the base foundation model capabilities. There's the agent engineering, but agent engineering is generic because agent makers cannot assume what code base you're working with, what tools are you using, right? So the missing link is actually in the tool chain. So with a unified tool chain, we're able to instill a lot of things that can instruct the agent to work more smartly, to tell it, hey, like you're working in a V+ environment. These are the commands you can use. These are the shortcuts you can take. And when we detect you're running using agent to use V+, we can give the agents more optimized CLI output, more structured, more condensed, and more token efficient, right? Like forwarding console browser errors to the console, making sure Vitest doesn't hang when the agent tries to run it. So all these little things, just making the tool chain work smoother with AI, working smoother with agents. This is something on the future roadmap. And the final thing is, like, why are we building V+, right? Because a lot of the things you get in V+, you do get them through the open source dependencies. The value of V+, as we see it, is org-wide standardization, right? So it is very clear that we did not design V+ for everyone, because I know there are people who just like the freedom, being able to pick and choose their own stack. But in a lot of teams that we've been talking to, right, this kind of fragmentation actually becomes technical debt if you just let every individual team in your company go with their own adventure and pick whatever they want to use. And if you just let that go on for a few years, it is also extremely hard to rail it back and finally re-standardize on things, right? So the value of org-wide standardization is really like focus on less bike shedding, less dependency management. You should be focused on shipping actual features, right? If you talk to your business manager, they all talk about, like, we need to ship features. I don't want you to just, like, how many times you've talked to the manager and trying to convince them you need to address this technical debt. We need to, like, upgrade this tool. And they'll be like, but that'll take away time for you to ship features. Okay, so we know that if you're already deep in the existing stack, it's probably also very costly to switch to V+. But the nice thing about being on V+ for the long run is that you can stop thinking about those problems, right? Having standardized tooling also helps developers' internal mobility and retainment. Just make people happy, make developers happy. They are willing to do better work. Centralized best practice enforcement, right? So a lot of times we see different teams doing things wildly differently, but you can't really easily enforce it because they are using something slightly different. So V+ gives you a sort of channel to sort of enforce best practices across the organization. So you have more knowledge reuse and people get more productive, right? So the value of V+ really is focused on large organizations with currently internally fragmented tooling across different teams. You want to offer this solution where you can actually say, look, here is something we can standardize on, and it will make us more productive. Okay, so a very key question many people will probably ask, how do you make money? And how do VoidZero make money, right? So like I said, the value of V+ is focused on organizational-wide benefits. We do want to keep So first of all, everything we've built so far as open source, that includes Vite, Vitest, Rolldown, and OXE, remains MIT licensed in open source and free forever, right? V Plus itself will make its source available, but it'll take a slightly different approach. We do want to keep it still free for the community. So V Plus will be free to use for open source, non-commercial, individuals, and even small businesses. It'll be a simple flat fee per year for startups of certain scales. And for enterprise, obviously, it's a case-by-case conversation. This is kind of tentative, and we're still tweaking, exactly where the thresholds should be for you to qualify as a startup or enterprise. But, this is why we are sort of announcing this early, so we can get these conversations going and figure out where to best draw these lines, right? So if you're interested, check it out at vplus.dev. The website is actually live, and you can register interest, and I'll give you a quick sneak peek of our fancy website. So everything you love about Vite, productivity, enterprise scale, everything you need in one tool. Format, run, UI, lib. You can also do full stack, right? It's not just a front-end build tool. There are many frameworks that ship as Vite plugins. It's platform agnostic, and you can pair it with Nitro. Keep your eye on the Nitro talk. It's going to be very important. Yeah, so check it out. If you're interested, talk to us, and thank you.